Okay, so the idea now is to talk about the race condition. Race condition is a situation in operating system with using processes that there is a shared data, shared resource. For example, in this example, a bank account that is shared between the two processes, process A and process B. And this shared resource can be, for example, accessed and manipulated by the two processes at the same time, and the result of what happens depends on which process did what and which time. And when both processes get to the shared resource at the same time, weird and abnormal things can happen, and that's what we are going to see right over here. So we have the shared data, we have the shared resource, and we have the two processes that will get access to it and manipulate it. So it's a bank, for example, there is money. Each one of them want to take $80 out, but they will come at the same time to the bank and take out the money. Now, before process A will finish to save what he did, process B already tries to do something after process A did what he did. So what happens? A takes $80 out, it's 20, but when B tries to take 80, he still read the 100 because process A still didn't save the data and process B didn't see the updated data. So process B took $80, but the calculation was from $100. So what we got is that two processes took $80 from the bank, yet the calculation of the bank was as though only one of them took $80. So this is a problem, this is a race condition. Both conditions race on the same resources, and their ordering of, we didn't see the thing of the ordering, but the ordering of doing things may be important. Here we saw that the race condition, by simultaneously changing or manipulating the shared resource before the first process finished updating and saving it. So we saw the race condition and the problem of this and how we solve it. We can use, for example, critical sections and mutex or semaphores to lock the resource while one process read or one process access and manipulate the area in the code that can access and manipulate the shared resource. So we lock this paragraph of code or area of code that is important for access and manipulate. While a process gets inside, we lock this area. We call it the critical section and do a lock by a mutex, for example. And only after the process finish this area, finish this critical section, only then we release this segment of code such that other processes, for example here process B, will be able to get inside, access the shared data and manipulate it. So in order to solve this race condition on the same shared data in the code, we use, for example, the idea of critical sections and close them by, for example, a mutex or a semaphore or binary semaphore or something. Okay, so this again was the idea of the race condition, and you saw here one problem of this, and that's it. Thank you very much.